Hi, Assalamualaikum. Good morning to all. I hope you guys finished the previous exercise sheet. So today we continue with the same sort of topic again, differentiation 1, but it's the application of the second derivative. We have two applications. This is the first one, okay? Okay, so the work for today is still differentiation 1. The width is stationary points or turning points. Stationary points and turning points means the same thing. Okay, some of the books they use stationary points, some of the book they use turning points, but usually in exam paper they're going to use the word stationary points. So throughout the lecture today I'm going to abbreviate because it's too long. So for stationary point or turning points, I'm going to use the word the letter SP only. So SP throughout this lesson today means stationary points. Okay, so stationary points or turning points, let's just fix to stationary points. Stationary points means the point where your curve start to turn. Okay, let's say I have like this type of curve. Okay, not a straight line, it's a curve. Okay, straight, a curve. Okay, so I'm going up, okay, and then at this particular point where I start to go down, so this point is what we call a stationary point, where your curve start to turn, start to change direction. So it can be like in this form or can be also in this shape here. Okay, where I'm going down. At one particular point, my curve is going up. So this is what we call a stationary point, okay, or turning points. Okay, so now if I ask you what is the gradient at this stationary point, how do we calculate gradient? So to calculate gradient, usually we will draw a tangent line at that particular point. Okay, draw a tangent line at that particular point. So when you draw a tangent line, you will get a straight line at these 2 points here. Okay, so what is the gradient of this tangent line? What is the gradient? So we recap a bit. If you have that shape of line, what is the gradient? So the gradient is just positive value because going up. If you have this shape of line, what is the gradient? Gradient is just equals to negative value. If I have one vertical line, what is the gradient? Gradient is just infinity. So now when I have one horizontal line like these two lines here, what is the gradient? The gradient is equals to 0. So whenever you have one horizontal line, the gradient must be equals to 0. Okay, so what do we know from here is, make sure everybody copy that. Okay, so what we know from here is, okay, at stationary point, gradient must be equals to 0. But in this chapter, oh blur. Wait. Why is it blur? Okay. But in this chapter, we don't use m as our gradient. So gradient simply means dy dx. So what you need to know is at stationary point, your dy dx must be equals to 0. So this is the first key point that you need to know for this subtopic. Okay, at stationary point, dy dx or gradient must be equals to 0. Why? Because stationary points occur at the point where the curve start to change the direction, that point or that point. So when you calculate gradient for that 2 points, that is just drawing tangent. So you will get a straight horizontal line. Straight horizontal line, what is the gradient? 0. Okay, so this is the relation that you need to remember. It's not given in the booklet. Okay, so you need to remember this. Make sure this is in your notes. This is very important. Okay, so maximum image. Okay, so next thing, can we do one second? Okay, so next thing is okay, let's say okay, this stationary point, stop.